Hi, I'm Laura,
I'm Matt.
And I'm Milan.
and this is our Smart Bee Hive. First, we determined what our customer needs were so we can build our product to them. Our customer is a hobbyist beekeeper who lacks the time to watch the beehive constantly, and they usually have smaller hives. In our interviews with our target market, we not only learned more about beekeeping, but about the pains and constraints that our customers face every day. The biggest pain that they face is a lack of information, so we want to get this information for them and fix the problem before it happens.
So, with our hobbyist customer in mind, we identified the benefits or the gains that they derive from beekeeping, the pains or what stinks about beekeeping, and the jobs that they have to do to maintain their hive. And through our brainstorming process, we believe we have identified the best ways to improve their benefits, the best ways to relieve their pains, and the best ways to do their jobs for them.
In order to better understand our three ideas, we built three prototypes to see how they would work. The first is a temperature sensor to help keep the internal temperature of the beehive constant. The second is a bee feeder to make sure that the bees stay full in the winter. And lastly, we used a weight sensor to try and make sure we knew when the honey was ready to harvest or when the hive was too dense. Due to time and resource constraints, we had to switch out some of the parts. For example, we used a DC motor instead of a heat source. We use these three prototypes to better understand the use of each of these three features.
The first component of our smart beehive is our bee feeder that has an adjustable smart valve for various applications. One main application is winter feeding, which is very necessary for beekeeping because the number one cause of hive deaths is winter starvation. With this entrance-style bee feeder, a beekeeper can insert the bee feeder into the hive directly so the bees don't have to leave the hive and feed them as much syrup as they need. However, thanks to the adjustable valve, you can also use it for other properties, such as delivering medication, so you only deliver the right amount of medication to the bees, or when the bees are producing honey, you're able to give them special syrups they will introduce into the honey to modify some of the characteristics of the honey, such as the viscosity, or the flavor, or the color of the honey.
The next system we built was weight sensing, and this system measures the weight of the hive every day to determine the amount of honey. And when the hive is full, the light comes on. It also determines the size of the hive, because when the hive gets too dense, it tends to leave. So we built in an expansion pack, so when the hive is too full, it will expand. So in the next slide, you'll see an example of this kinematic prototype.
The last feature that we built into our smart beehive was a temperature sensor. This is put in this hive in order to keep the bees warm during the winter. One of the big reasons why bees die out in the winter is weak hives can't keep themselves warm. So if we have a heater in the hive to keep them warm, the bees will be healthier for the spring and summer to come. Due to lack of resource constraints, we had to substitute a heater for the motor and a light sensor for the thermistor. However, the concept still works and shows that this could be possible in the future.
So we proved that we met our customer needs by combating the three main reasons that hives die in the winter, which is feeding, expansion, and heating, and we built in a honey estimation system. This completed our primary goal of getting information and solving a problem before the customer needs to.